Right, so let's solve this integral equation for an unknown function using the Volterra integral. I don't know if you're meant to roll the R's, but we're going to roll the R's. So as a Volterra integral equation of the second order with a convolution type kernel of k, t minus, we're going to call this one the squiggly boy t, which equals 4 t minus, and then another squiggly boy t there. We know that the Laplace of a function t is fs, and we should recall that the Laplace of this, I'm not going to write it out again, equals, not this, it's going to equal, so this equals, so pretend I've put a squiggly L here, is going to be fs over s squared. But because we know that the Laplace t would equal 1 over s squared, and the convolution in time is multiplication in the Laplace domain, we can Laplace up both sides. We're just on a Laplace spree right now. So let's Laplace, let's Laplace, you know. So we're going to have a Laplace of ft plus 4, and let's put another Laplace of the integral of 0 to t, t minus squiggly t, f, let's do a squiggly t, there should be a brackets there, and let's do a d squiggly t, which equals the Laplace of the t. We're just on a Laplace spree. Oh, spitting bars. Okay, so we sub above, and so we're going to substitute all of the above. So let's recall that it would then become fs plus 4 fs over s squared, which equals 1 over s squared. That substitutes this substitute this, ft just becomes fs. Nice. You thought this was all just random stuff going on. Nah, it was part of the plan. So we now have that, and we can now factorize fs. So let's get rid of this fs out of here. You're going to get 1 plus 4 over s squared, which equals 1 over s squared. So so actually no, we can rearrange this and put this in terms of fs. So you're going to get 1 over s squared and 1 plus 4 over s squared. Yeah? And then that's obviously going to become 1 over s squared plus 4. But we still need to inverse it up. We're going to now inverse Laplace this. So that's like that, minus 1 there, and it's going to be 1 over s squared plus 4, which equals a half sine 2t. So that means that ft would equal a half sine 2t. This leap's a bit crazy, and this video is not about Laplace, but okay, I'll explain how it goes from there to there. So obviously, I'll do this quickly, is sine at would equal a over s squared plus a squared. This is something that you must remember. But the inverse of Laplace is obviously you're Laplacing this, so that's going to be a over s squared plus a squared, which equals sine at. And we know we've got 1 over s squared plus 4, so 1 over s squared plus 4. We now want that to look like this. So we need these two numbers, these a's, to be exactly the same. That's a 1, that's a 4. In my world, that's not the same. It's just not the same. So we need to now sort this out. If I pull out a half, so let's say I do a half here, and do 2 over s squared plus 4, guess what? A equals 2, and that means a squared equals 4. I've done it. So now a is 2, and that means a squared is equal to 4. So this would be equal to sine 2t, where a equals that. But remember, we pulled the half out, so it becomes a half. So that's how the answer is done. Saying that, if you obviously know how to Laplace stuff up, because this is a Laplace one, then you don't need to care about any of this. But that is the answer.